So let's find the area between the two curves, and notice that I've shaded it in yellow and I've given the curves specific equations. So the first one's a parabola, the blue one, and the red one is a straight line. And if I want to find the area between the two curves, the first job I have is to find out where they intersect. And they intersect where x squared minus 4x equals 2x. I'm going to subtract the 2x from both sides and then factor. So I get x minus 6 equals 0, which means that the one is 6 and the other 0 and the other one is 6. So that gives me my areas of integration, and I'm going to do the two areas. I've got the area of this one, which is the integral of 2x dx between 0 and 6, minus the other one, which is this area. So it's the area of x squared minus 4x dx between 0 and 6. And what the reason it's minus is because this is minus area, so it's going to, when you subtract it, it turns positive, and that allows you to calculate the whole area. I'm going to write this as a combined area because notice that the integrals, the constants of, the limits of integration are the same. So I'm going to write it as 0, 6, 2x minus x squared plus 4x. This minus sign gets distributed, and so this turns into a plus. And then one more time, I'm going to simplify. So I get 0, 6, and 2x plus 4x is 6x minus x squared dx. Now I'm actually going to do the integration, which would be using the general power rule. So I'm going to increase this exponent by 1, so it'll be 6x squared over 2 minus x cubed over 3 evaluated between 0 and 6. And I'm going to just simplify that before I put in my constants. So it's x cubed over 6 going from 0 to 6. And if I evaluate that, I'm running out of room here. I'm going to plug the 6 in first. And 6 cubed over 6, and then subtract 0, which is 0. And that equals 36. So this area here is 36 units squared.